Hello, good evening, all of you. Very good evening to all present here. Am I audible?
Yes, ma'am, you are audible.
Okay. So today is our third day and third day of our first session. It's already 6:05. I think we can start the session.
Hello, good evening all. Am I audible?
Okay. So this is our third session, as I said, and our first third day of our first session. So for that, I invite Mr. Pradeep T. Is a seasoned data science professional with nearly 7 years of experience, specializing in agentic AI and advanced intelligence systems. He is an accomplished AI trainer and mentor, having successfully conducted over 100 AI training sessions for the students, educators, and working professionals across Kerala and beyond. A published AI writer and sought after speaker, Pradeep regularly shares insights on emerging AI trends, future technologies, and real world applications of artificial intelligence. He is also a passionate open source contributor committed to strengthening the AI ecosystem through the collaborate innovations, knowledge sharing, and community driven development. We welcome you, sir, for this session.
Thank you. Thank you. Am I audible?
Yes, sir. Yes.
Okay. So we can start, right?
Yes, sir. You can start your session.
Okay. So good evening all. So first of all, thank you for the invitation to this FDP. So in this around 1.5 hours, let me try to share my thoughts regarding the agentic AI. Okay. So let me share my screen and let me know whether my screen is visible or not. So my request you host, can you enable the screen sharing, showcasing the disabled screen sharing for me? Any host is there, Rishila?
Yeah, sir, can you try now?
Let me try. It's second showcasing. Host disabled the attendance screen sharing. Could you check the settings?
We are trying, sir. One
Yeah.
minute. Sir, but once you click on the share screen or something, then we will get a notification to permit, allow like that. So
Okay.
can you
Let,
give
let
a
me
try?
let me let me click on the share screen. Yes, I clicked. Yeah. Check now in your section.
Share, if you click, then it will ask send request.
No, no. I'm only seeing one dialog box. I send you the image in the WhatsApp. Could you please check?
Okay. Okay. 1 second, sir. 1 second.
Amal sir.
Yeah. Sir, can you try now?
Yes, now I think it's working.
Yes, now it
Is
is
my
fine.
screen visible?
Yes,
Now
yes,
is my
yes.
screen is visible, right?
Yes, yes,
Okay.
yes. Thank you.
Okay,
Thank
yeah. Thank you. So let me start.
Sure, sure.
So yeah. So today's our topic is building agentic AI systems with architecture, tools, and workflows. Okay. So before that, so I'm going to cover a basic understanding regarding the key characteristics of AI agents. And I hope that you already have a basic understanding, or I think already there was a session regarding that agents, right? I hope. So I'm simply showcasing key characteristics of the AI agents. Then what are the building blocks of agents? Then what is multi-agent systems? What are the importance of tools and workflows? What are different layers in multi-agent systems? After that, I can showcase you a very small demo with hacking face models. Then finally, a Q&A session. Okay, this is how I'm planning. Okay, so I hope you are already aware about the concept of agent. What is an agent? As I already mentioned, I assume that there was a session regarding the AI agents. Is part of the FTP. So my sessions, I'm more focused on the enterprise level application, or how we can able to leverage the agents in the enterprise level scale. So let me take around maximum 5 or 10 minutes to give you an understanding regarding agents. So what is an AI agent? We know that an AI agent has its own abilities, its own goals, and prior knowledge, and it will work in an environment by doing the actions. Then, based on observation, it will repeat the action or it will stop the action. Okay, this is how an agent is working. So to do this kind of to access the abilities, preferences, and prior knowledge, everything, we need a agent has three components. The first component is a perception. Second component is a cognition. Third component is a action. So perception nothing but how the agent is obtaining, or how the agent is getting the data. It may come from AWS camera, it may come from the text, it may come from the maybe APIs. Multiple options are there. Then the cognition model means that how it is processing. Okay, so for that it need memory, knowledge base, everything, and action in the sense how it is executing the action. So perception model is there, cognition model is there, and action model is there for each and every agent. So in even if we are leveraging the memory, then definitely there are short-term memory and long-term memory. If they're leveraging tools, again there are we can able to use multiple kind of tools, calculator tool, calendar tool, multiple tools, and these are other kind of patterns. Okay, these are the some overall nature of the agent. Okay, so what are the key characteristics of a agents? Why I'm going very fast? Because I hope that you are already aware about the agent. That's why. So I'm mainly focusing on the enterprise level use case of agents rather than the basic concept of agents. Okay, that is why I'm changing my slides faster. So what are the key characteristics of AI agents? Autonomy, perception. We know that it should be work on autonomous nature. Then it should gather data from the environments. Then it has the ability to take the decision making. It should act in the environment. And every data or every action should be in for the goal-oriented manner. Okay. So these are the key characteristics of AI agents. Then what are the building blocks of agents? We know that from this image, we understand that every agent need its own environment, which means the context where the agent is working. Then every agent need its own tools. Its own tools. You see, we need our own tools. Without tools, agent is simply a LLM. Okay. So tools are the another building blocks of the agent. Then the effectors. Effector is nothing but how the agent is communicating inside or between the agents, or how it is passing the message. That is effectors. Then definitely the important concept or point is or fact is the or compound is the reasoning engine. Generally, we are using an LLM. Then the knowledge base, the repository of information the agent uses to make decisions. Okay, these are the building blocks of each and every agent. So I'm repeating my task. I'm the topic. So based on this information, building blocks and the key characteristics. Now I hope you got a better understanding. An agent has its own goals, its own abilities, and its own prior knowledge. Based on its goal, abilities, and prior knowledge, it work in an environment by executing the action, and it observe the actions, and it will repeat in a react manner or a n number of manner. Okay, so now I'm going to my major section or important section. What is this is an agent. So what is an agent AI? Okay, so if we are using simple LLM, we are passing the question to LLM, we are getting the response. It's not an LLM, it's not agent AI. Similarly, if you are using some LLM and there are some kind of deterministic tools, that is also not an LLM, not an agent AI. Similarly, if you are using RAG, we are using embedding, we are using MetaStore, that is also not an agentic AI. What is agentic AI? User is passing the query, and that LLM working as orchestrator, it uses consumes the memory, it doing some kind of planning, it using some tools, and there are some kind of multiple will be the coding agent, travel agent, citation agent, and it will do everything its sound. It will do the feedback. It will execute the tools. They again consume the memory. So this is agentic AI. Okay, don't confuse that. If you are using LLM with a simple tool, that's an agent. Don't consume that. Don't assume that's not correct. Okay, that are simple deterministic workflows, but this is an agentic AI. Now, the important thing is that AI agents are 90% software engineering and 10% is AI. Don't assume that the agent is the agentic general intelligence. This is supernatural AI. Not like that. In reality, in enterprise level, the 90% is software engineering or classical engineering. Only 10% is the AI in the case of AI agents. You see, in the AI agents, we have multiple components like GPU and CPU providers. For that, definitely we need NVIDIA and Azure, AWS, etc. Okay, it's an AI? No, it's not an AI. These are simply software components. Once we get a GPU or CPU provider, definitely we need infra. Okay, for to make it more scalable manner. For that, we need Docker and Kubernetes. That's also not an AI. Then definitely to store the memory, we need the database like Chroma, Qrent, etc. For the enterprise level use cases, for the ETL or extract, load, and transform, we need ETL based tools. Definitely, we need foundation models like a reasoning engine. Otherwise, there is no agent AI concept. So the OpenAI, DeepSeek, Gemini, these are the LLMs we are using in the agents. Then for the model routing, we are using other tools. Then to communicate between the agents, we are using agent protocols like A2A from Google, MCP from Anthropic. Definitely, then for the agent orchestration, we are using Langflow or LangGraph, etc. Then to provide the more security in the enterprise level system, we are providing the authentication like zero author authentication and another authentication. Multiple options are there. Then definitely we need the observability in our agents. Okay, because without each and every action user is doing or agent is doing, it should be traced somewhere. So we need agent observability. We need some tools for that. Then for front end, we need Samlite and some multiple options are there. So the overall idea of this particular image is that AI agents are 90% of the agents are classical engineering. Okay, only 10% is the AI. Okay, so I'll share this PPT with you. So these are the slides we are covering the same thing. So by using everything, by using the tools, by using the model routing technologies, by using databases, by using infra base, by using GPU, what our agent is doing, whenever there is a user input, the LLM will decide whether the user or the query can solve using any of the tools, If it can be able to do the tool, it will execute the tool. The tool may be web-based tool. The tool may be weather API tool. The tool may be RAG API tool. The tool may be search API tool. Then it will find or it will observe the observation. If the agent understand that, okay, my actual result is not obtained, then what happens? It again goes back to the LLM. It again execute tool, again go to observation, again check whether my actual result is obtained. If not, it again go to back to LLM and execute tools. So it will be a cyclic manner, or a what we can say in a looping manner. Once we got the agent, once we got the desired output, then only it will return back to the user that once I got the output. So to do these kind of things, what do we need? We need these kind of things. Hello? Okay. To do these kind of things, we need this kind of n number of, or this kind of classical software engineering tools. Without tools, only using AI, we cannot integrate the enterprise level AI agents in real world. Okay, it's very important. Without these classical engineering tools, we cannot integrate or we not deploy a agent in the enterprise level use case, which is very important. Okay, so that's regarding single agent. Now we are going to multi-agent. Okay, so this is one agent that we are doing. So what happened in the multi-agent? We know that a single agent is an agent that handles the reasoning, planning, and action, everything. But in the actual enterprise level, a single agent is nothing. Is nothing. Nothing in the sense we cannot able to solve a enterprise level use case using single agent, because the enterprise level use cases are always very messy. There are lots of false points. There are lots of multiple tool calls. So a single agent cannot be able to solve a enterprise level use case. Even if using multiple kind of this kind of architectures and multiple tools, it cannot be able to solve the actual enterprise level use case. So we need multi-agent. So what is multi-agent? Multi-agent nothing but a collaboration of single agents for solving a particular goal or a specialized goal. Okay, definitely it has its own disadvantage. Like if there are multiple agents, definitely our system is more bigger. We have to integrate more number of components. So there is a huge chance of failures and communication overload. Everything is there. But if you're handling this in a clear or a graceful manner, then our multi-agent system can able to solve our enterprise level use cases in very good manner. Okay, so to integrate multi-agent, we need to understand that the tools, workflows, and orchestration in multi-agent systems. So let me showcase you the tool section. So what are tools? Tools are the functionalities that enables autonomous AI agents to perform actions in real world. Okay, for example, a search API to get real-time data, or a book a ticket in any kind of platform. So these are the eyes and hands of an agent. There are tools, very important. So what are multiple kind of tools? The tools maybe can able to access data, it can able to execute a code, it can able to analyze the data. So multiple kind of tools possible. So tools are the eyes and hands of an agent, we can say. So let me showcase you some principles when we are building the tools. Whenever you are building a tool, always go to or provide a single responsibility. Okay. For example, instead of manage data, it should be clear, like search database or insert record or update record, something like that. Okay. Similarly, instead of your principle should be clear contract you have to provide to the user, to the agent. Like instead of providing vague parameters, you have to provide a strong typing. You have to provide a strong validation, everything. Similarly, instead of a granular or combo, which means a one tool that searches and filters and sorts. For example, if you are using a tool that is responsible to searches, filters, and sorts, it's not a good manner. It's good behavior or a good pipeline. You have to always use separate tools for each and every use case. Similarly, always try to provide return a structured data to and from of the tool. Okay, for example, instead of returning a long text, always return the JSON. instead of providing a long test, always provide the JSON. Okay. So these are the some fundamental enterprise level coding standards you have to keep in mind when you are building the tools. Okay. Then those are the tools. Now, what are the okay? This one we already covered, right? Yeah. Then what are workflows? Workflows is a series of connected steps dynamically executed by an agent. Okay. So it's nothing but a number of steps or a deterministic steps that is executed by an agent. For what? For achieving a specific task or a goal. Okay. So as I already mentioned, a single agent cannot able to, or a multi-agent system cannot able to solve our enterprise level use case. So for that, we need our workflows. So you see, this is an automated workflow without AI. You see, nothing is there. Nothing in the sense there is no AI model. Then there is an AI workflow, but without agent or non-agentic. You see, user is passing the query, the AI model is act on the query, we are getting the response. Then finally, we have a agentic workflow. What is that? User is passing the query, and a agent make a plan or a understand the query, it decompose the query, execute tools, reflect its sound. Again, it's back, return back to the agent. It's a loop. Okay, it's working. Finally, we are getting the response. So these are the workflows. Okay. So again, in the workflow, we can have multiple patterns in the workflows. Okay. I'm not going to showcase you one by one because we have only around 1.5 hour, maximum 1 hour we have. So let me cover very fast. Okay. I'll share the PPT with you. Okay. So in the workflow, we have planning pattern, which means a user query we have. That particular user query is decomposed in multiple sub-agents. So sorry, subtasks. And each task is handled by the agent to achieve the goal. Then in the workflow, we have to use pattern, which means the agent is executed the tool. Then we have a reflection pattern, which means the particular agent is critic itself, like it is checked whether the output is correct or not by itself. That is the reflection pattern. So multiple patterns are there in the workflow. Then what are orchestration in the AI agent? What is a orchestration in the AI agent? Very important. Don't assume that my screen is visible, right? Is my screen visible? Hello? Is my screen visible? Anyone?
Yes, our screen is visible.
Okay, thank you. Yeah. So don't assume that using workflow, we can able to solve all the enterprise level use cases. It's not like that. We need orchestration. Okay, so what is orchestration? This is the what we can say a super global class. Okay. So what is happening in orchestration? An AI agent orchestration is a process of coordinating multiple workflows, or it may be multiple multi-agent system with tools to define or what we do what for what to on a solve a complex task. Okay. Why we are doing saying that? What is the purpose of orchestration? Assume that you are building an agent in Azure, agent one. Assume that you are building another agent in AWS. Assume that you are building a third agent in GCP. How you can able to communicate each and everything? You cannot able to do. Okay, you cannot able to do that. How? Because you don't have orchestration. Once you have orchestration, then only you can able to execute the agents in multiple clouds. Okay. So in practice, a agent orchestration function like a digital symphony. What is happening in a musical symphony? We have a violin, we have a what we can say another musical components. Then everything communicating or everything work together to create a beautiful music symphony, right? Similarly, agentic orchestration is a digital symphony that will communicate or that will orchestrate multiple agents together to achieve or to create a beautiful agentic orchestration system. Okay, why it is important? Why it is important? So, as AI system grow more advanced, a single model is often insufficient for handling complex tasks. And we are not saying a lab level task. We are not saying a demo level task. We are saying a enterprise level, scalable, governed enterprise systems. Okay, I'm repeating the word scalable, governed, persistent, reliable agent systems. To build that, definitely we need agentic orchestration. Okay. Otherwise, what happen? Without orchestration, our agents work in isolation. That's okay. If we are working, executing our agent in my system, I got 90% accuracy. If you're executing your agent B, you are getting 89% accuracy. That's okay. But that agent is only relay, or that is only stay in your machine until and unless you are using orchestration. Okay. To leverage to collect the full potential of your agent, definitely there should be a orchestration system. Otherwise, you cannot be able to execute your agent in a full potential manner. Okay. So again, similarly in the workflows, in orchestration also we have multiple kind of orchestration. We have sequential orchestration. We have like each agent. You see, each component is nothing but an agent. It's a workflow. Okay, it may be a single agent, it may be a workflow, or it may be multi-agent system. Okay, don't assume that, or don't confuse that it's a single agent. So what is the orchestration? Sequential, which means one output of the one workflow is passing as the input of the another. Then output of the that is passing to the input of the another. For example, you see a template selection agent is passing to clause customization agent. Then it is a passing to regulatory compliance agent, etc. So you see this agent may stay in Azure. This agent may be deployed in AWS. This agent in our local machine. How? With the orchestration, how we can able to communicate? It's not possible, right? So that is the importance of orchestration. So these are the sequential pattern. Now we have one more pattern, which is called concurrent orchestration. It's entirely opposite. Sequential, which means the output of one agent is going to input of as the another. But what happened in the concurrent? Concurrent is nothing but every orchestration is happening triggered in a parallel way, which means a concurrent orchestration pattern runs a multiple agents simultaneously on the same task. Okay, the agent 1, agent 2, agent 3, and agent n. I'm repeatedly saying agent 1 is not a single agent. There are multiple sub-agents. Okay, similarly, agent 2 have multiple workflows. But those will work in a concurrent manner. For example, you see a what we can say a stock analysis agent. We are analyzing the fundamental analysis of the stock and technical analysis of the stock, sentiment analysis of the stock. This can be done parallel, right, or concurrent, right? So there is no need for a sequential nature. That is concurrent execution. Then we have a group chat execution. Group chat is nothing but we are putting a topic to a group of agents and they are communicating each other. Okay, this is the group chat orchestration. Then, for example, you see I'm proposing a proposal to a group chat agent system workflow for orchestration. Then there is a community engagement agent is there, environmental planning agent is there, parts budget and operation agent is there. They are communicating with each other and we are getting a proposal. We are getting the output. Okay. Then finally, there is a handoff orchestration. Handoff orchestration is similar to group chat, but it is more focusing on the handoffing. Like we are passing one out task to an agent, but that particular task that is more native to another agent. Then what happened? This agent handoffing to that task to that agent. Okay, so this is similar to group chat orchestration, but more focusing on handoff. For example, we are asking a question like a trial support agent, then it will go to technical infrastructure agent, it will go to financial solution agent, but the technical infrastructure agent got a query regarding finance, so it identified that okay, there is another agent, so I have to hand off to that, so it hand off to other. Similarly, if the financial resolution agent will hand off the account level questions to account level queries to the account access agent. Okay, so the handoffing is more important in the handoff pattern in the orchestration. Okay, so whatever it is, again there are multiple kind of orchestrations are there, like reflection, multiple items are there. These are some number of items. The problem is there is a paradox of agent complexity. Like building a demo agent is very easy. Nowadays, anyone can, any SLC student can able to build an agent, very easy. Because there are n number of no code or low code applications are there. We can simply change some LLM and plug and tools and we can build work. But as the agent becomes more capable, as we mentioned, through the workflows, through the orchestrations. When the agents are becoming more capable, it becomes more fragile. This is important thing because the more steps means more failure points. More state means higher memory pressure. More iteration means we have to put higher cost due to redundant work. So the agentic complexity paradox is in enterprise level, more powerful agent can have or are more likely to fail catastrophically. Don't assume that the more powerful agent will never fail. It's like entirely opposite. More powerful agents are more likely to fail catastrophically. So the critical gap between the prototype and production is persistence and reliability. So as I already mentioned, we can able to create a prototype of demo agent very easy. But to make it production level, to make it enterprise level, scalable, persistent, reliable, governed agent, we have to focus on persistence and reliability. Okay, otherwise what happen? Our demos, our agent is only stay in our demo. We can't able to push to production. So to integrate that, we have to integrate multiple layers in multi-agent system. Why? Why we are using multiple layers in agent system? Because as I already mentioned, as the agent capability increases, there is a huge chance to fail. Okay, to ignore that, to remove that, we have to integrate that multiple layers in multi-agent systems. So these are the what we can say some kind of pillars of agents, enterprise level systems. We need a clear structure. We need interoperability. We need the agent should be highly scalable. Agent should be observable. Each and every action the agent is doing. It may be a tool execution. It may be a task handover. It should be logged. It should be traced somewhere. Okay. Then our agent should be governed. Okay. So what is that? To integrate these five items like structure, interoperability, scalability, observability, and governance, we have to follow some architectural principles, in our AI agents in enterprise level. As I mentioned, the AI should be goal oriented. These are the 8 items. Definitely, each agent system should be composability, like a modular design is the preferred one. Then explainable, as I already mentioned, each and every task should be explained to the users. Then human in the loop, like if the before the agent is going to execute a critical task, always better to ask the user or the human or the confirmation. Then the trust before automation. Yes, we have to provide the autonomous nature to our agent. But before we are providing the full reliability, the full independence, make sure that you can trust your agents. So prove reliability is very important. Then instead of rely on the request response paradigm, it's always better to go with the event driven paradigm. Then the continuous learning that I can showcase you in the last slide. Then the bounded freedom. Definitely our system should provide a freedom, but should be always bounded within policy limits. Okay. These are the core architectural principles you have to keep in mind when you are building the agents. Okay. So what are the different layers? What are the different tiers in the enterprise level system? So you see, these are the architectural pillars I already mentioned. So there are a 3-tier reference model every enterprise level agent should focus on. So a 3-tier reference model. First tier is the foundation tier. Second tier is the orchestration tier. And third tier is the autonomous tier. What is a foundation tier? So what is a foundation tier? Foundation tier is nothing but it's dealing with the data, because we know the agent is able to work on the data without a proper data context. Our agent cannot do anything. So providing the data in a proper manner, in a knowledge-based manner, and data ingestion, these kind of things happening, or security, governance, everything happen in the foundation tier, the data and platform core. Then the second one is the orchestration tier. What is that? Once we got the enough data, then it's time to orchestrate each and everything. So there we are using the agent history. We have stored in the discovery of agent, directory of agents and everything. Then the workflow engine, patterns and integration, then shared memory between the agents, human escalation point. These are coming in the orchestration tier. Okay. The third one is the autonomous tier. What is autonomous tier? That is some kind of higher level. You see, we are goal planning, cell optimization, dynamic rule allocation, and guardrails everything. So user is always deal with the autonomous tier, or this is the user readiness or a user friendly layer. Not layer, it's a tier. Okay. Then autonomous layer. Below that or between that, there is orchestration layer, and this is the foundation layer. That is a data and platform code. So I hope you are getting the point. We have to implement the principles, these 8 principles. To implement these 8 principles, you have to make sure that our enterprise level, reliable, governed, and persistent agent has a 3-tier reference model, that is foundation model, orchestration model, and autonomous tier model. And to implement these tiers, to implement these tiers is very important. To implement these tiers, it's very important. We need a 8-layer architecture in agentic AI. Okay, 8-layer architecture in the enterprise level AI. Yes, you don't need to bother about this layer architecture if you are building a demo agent. You don't need to bother about these architectures if you are building a lab specific agent. You don't need to build about these kind of layers if you are going to build an agent to demonstrate it to your students. But if you are building a enterprise level, scalable, reliable, persistent, governed agent, you have to think and implement all these layers from the first day itself. All these layers are not optional. These are the must-have layers for every agentic enterprise level agentic systems. Okay, let me go to one by one. The first one is the infrastructure layer. Okay, you see in the infrastructure layer, what are the important components? GPU, similarly data centers we have, storage, S3 bucket, everything. Okay, so the first is the infrastructure layer, the foundation everyone underestimate. So you don't build the agent or a foundation layer from scratch. Okay, don't build it. Always use the battle tested solutions like AWS or Azure and everything. Okay, your goal is not build a your goal is not build a infrastructure. Your goal is to build a proper orchestration of agents. Okay, so always choose the best orchestration or infrastructure providers in the market like AWS, Azure, or GCP. Okay, definitely you have to give some money. It's not completely free. You have to make some payment. You have to subscribe. Then you have to use. But always don't try to make it from scratch. Then it will never, your agent system never will complete within 1 month or even within 1 year. Okay. Then the second agent, what is second layer? The agent internet layer. Or you see what is happening in the agent internet? There we combine the communication protocol and multi-agent systems, agent memory, short-term memory, long-term memory is there, embedding store, and multiple states are there. So these are the agent internet. So we are going to, in the enterprise level, we are going to create the or build the ecosystems, not islands. Not islands, which means there is no scope for creating a powerful individual agent that work in silos, but missing the exponential value that comes from the agent collaboration. Okay, so building ecosystems where agents can discover each other. We have to create an ecosystem where each agent can able to discover each other, each agent can able to collaborate each other, each agent can able to delegate tasks to and from each other, each agent can able to negotiate each other. Okay, so you have to think about the agent registries. It can MongoDB, Postgres, anything, and discovery protocols, load balancing, and conflict resolution mechanism and everything. Okay, this is second layer, agent internet layer. Then the third one is the protocol layer. So, what is protocol? Protocols are the language that the agents speak. Can you imagine an internet without TCP/IP? No, right? We cannot imagine an internet without TCP/IP. Similarly, the agents should communicate with each other. In the internet, we are using TCP/IP. Similarly, in the enterprise level system, we have to configure some protocols to come to make the reliable communication between the agents. We are using A2A protocol from Google and ACP protocol from IBM or MCP protocol from Anthropic, everything. Okay. So always choose the battle tested or the market leading protocols. Make sure that your agent is capable to communicate with through that protocol. Okay, before going to build the agent system. That's very important. That is a protocol. Then the fourth layer is the tooling layer. As I already mentioned, tooling are the agent's hands and eyes. Okay, so you can create a RAG tool, you can use a web scraper tool, you can create a Wikipedia tool. Before determine whether your agent can actually doing the things instead of simply talking about doing the things. What happens generative AI in the chat GPT? It is simply showcasing us that we can do this, you can do that, etc. Right? It's not doing the things. But what happens agentic AI? It should do the things. Okay, instead of simply saying it should do the things. So for that, we need to integrate the tools to our systems. So make sure that your tools are reliable. Okay, your tools, you have to integrate a multi-retry mechanism. You have to integrate the rate limiting mechanism. You have to integrate the fault tolerance mechanisms, everything. Okay, so you have to integrate necessary security levels and proper error handling. Everything is important when you are integrating the tooling layer. Okay, so the another layer is the cognition layer, where the exact brain of the agent. You see the agent's brain. So this is the actual magic happen, or the task dedication or a task planning is happening. Planning, decision making, which tool to work, use one, which agent to collaborate, which task to delegate to which agent. All these items are happening in the cognition layer. So planning, decision making, error handling, metacognition, everything. So make sure that all these should be observable. All the cognition tasks and cognition items it is deciding is should be observable. You can't optimize what you can measure. It's very important. Okay, so observability is very important. Observability is very important each and every layer, especially cognition layer, because you have to understand that why your agent took this particular decision, why your agent took particular this tool for this particular time. So everything should be traced or logged somewhere. Okay, so cognition is very important. Then the another layer is the memory layer. As I already mentioned, without memory, this is your agent's personality and context. Can you imagine a system that asks all your information, all your history every time? It's not reliable, right? It's not that much, it's not user friendly. So what happened? You have to provide a working memory or a long-term, short-term memory to your agent systems. Okay. So without persistent memory and user modeling, every interaction start with from zero. Okay. So there should be a working memory, there should be a long-term memory, there should be a user modeling, episodic memory, everything. So you can use vector DBs and other components. Nowadays there is a component called langmem. It's a new package that will be act as a tools to provide memory to your agent system. So memory layer is the not a option layer. This is the must-have layer that you have to think about from the day one itself. Okay. Then the seventh layer is the application layer. Application layer nothing but how you are able to what users actually see. Okay, so always don't provide false promises to your agent, to your users. Don't say that your agent can do this, your agent can do that, but actually your agent cannot be able to do that. So make the agent's capabilities and limitations clear to users. Very important. Okay, these are the application layer. Then finally, the very important layer is the governance layer. It's very important because your agent provide zero return of value until and unless it's deployed or it's pushed to the deployment or the production. So, whenever you are creating the agent, from the day one itself, you have to think about that the deployment strategy. What happened? My agent is happening triggering or deploying in the staying in a production AWS or wherever it is. So that is the governance layer. The impressive demo becomes a $100 liability if you cannot ship to enterprise customers. Like you showcase a demo and your customer is interested on it, and they put some what we can say some kind of $100 in your agent system, but within 1 month you cannot able to deploy or push or ship your agents to their infrastructure, then it will be a liability for you, right? That is the production reality. And you have to provide the compliance, audit trial, security, monitoring, deployment, everything should be reliable. Okay, a good governed system turns your AI system from liability to a trusted business asset. So all these layers are mandatory to build a enterprise level, scalable, reliable, persistent governed systems. I'm focusing three words: persistent, reliable, governed, because these are very, very, very important in enterprise level. Reliable means we are not claiming, we are not asking that we are always getting 100%, 90% accuracy. Even we are getting 60% accuracy, every time we have to get 60% accuracy. That is the reliability. Then what is persistent? Should be persistent. Otherwise, user should provide details every time. Then what is governed? Governed means observability. Like each and every task should be observable to the user. Not only observability, the shipping and the auditing, everything, deployment and everything. Okay. These are the 8-level architecture of your agent system that you have to take care of. Then what happened? What are the production reality checklist? You see the architecture. Always start with a simple and possible solution. Okay. Don't integrate the complex solution from the day one itself, but start with a simple possible solution. Add complexity incrementally with the ARB testing. And you have to measure the workflow complexity, thus add complexity, improve outcomes. Then use workflows before agents when possible. Okay. Whenever we can able to start integrate workflow, you can integrate that. Then the production reality context. From the day one itself, we have to provide your memory system to your agent. Okay, you can able to use the prompt caching, you can able to compress and summarize the context and everything. Okay, then tool section. Always use, as I already mentioned, use the single responsible tools. Each tool should perform a single task only, not multiple tasks. So provide the clear and what we can say a type checking, detailed description, strong input validation to your agent, everything. Then error handling. Error handling is applicable for sub-agent, workflow, tool, and everywhere. So you have to provide retry logic. You have to provide rate limiting. You have to provide multiple recovery strategies like fault tolerance, graceful regradation, and human escalation. For example, if there is a human in the loop, we have to provide to human. Then similarly, safety. What is that safety? Each agent cannot able to access each and every system. So permission, you have to make sure that your agents are permission or allow list should be there. Then if there's a critical action, always ask the output or input from the user, that is human in the loop. Then if your agent is or executing any code, if your agent is executing any code, always try to execute this in the sandbox. Otherwise, what happen? Our entire system may be in a trouble. Okay. Then observability. Like as I already mentioned, each and every task that an agent is doing should be observable, should be traced somewhere. Okay. Then the testing of the agent. You have to test one by one. Unit testing, end-to-end testing, and enterprise level testing, failure injection testing, everything you have to do, load testing, stress testing. Then the cost control. Definitely, if you are doing the cost OpenAI models, it's very expensive. So you have to provide the rate limiting and the model routing, like simple model can able to solve for simple queries. Complex queries should go to the complex questions or some complex agents, everything. and cost alerts, regular cost analysis, everything. Okay, so these are the production checklist you have to take care of when you are building a enterprise level, scalable, governed, persistent, reliable agency systems. Okay, very important. So the production reality is, the actual production reality is, agents will fail more than you expected. Okay, it definitely will fail more than you expected. Observability is non-negotiable. Cost control requires constant attention. Human oversight is remain critical. And very important that always don't overthink. Simple solution beat complex ones. Very important. Okay. So these are the other layers. I'm not going to showcase this again and again. Then I'm showcasing you a latest strategy, which is the self-improving agent with dynamic tool calling. As I already mentioned, in the old approach, what we have a fixed tool set. We have a calendar tool, we have a timetable tool, we have a what we can say web scraping tool. Then what is happening in the dynamic, or what happening in the, what we can say, I'm saying this case, you see, continuous learning. I'm saying the continuous learning paradigm. Okay, what happened in the continuous learning paradigm? You have to provide a new approach, what is called dynamic tooling, right? Like whenever agent require a tool, it should create by itself instead of checking on the fixed tool list. It create the tool itself. Automatic tool creation is happening. Okay, then that is, this is the, nowadays the industry is moving to this kind of dynamic tooling or a adaptive agent system. Okay, similarly, what happened in the self-improving agent or a adaptive agent? Currently, what happened in the old approach? This is the old approach, in the sense existing approach. We have our own system prompts and our instruction to the agent. But what the industry, where industry is moving towards a new approach where the dynamic system prompt is happening. Like whenever agent is struggling to generate output, it create or it modifies or it updates its own system prompt. So there is no need for a user to sit again on the agent to create it. So these are the dynamic level system prompt. Okay, so nowadays the enterprise level systems are going to this kind of self-improving or adaptive kind of event-driven agent systems. Okay, so I'm just showcasing this, right? That's only. Then the foundations of agentic AI tech stack, the same thing we mentioned. We need input layer, we need output layer, authentication layer, and tool call layer, everything. Then the agentic system and agentic AI lifecycle, like our scope and everything. Okay. This is only, I can showcase you the, I'll share the PPT with you. Then now I'm directly go to the demo. Okay. Okay. Before that, there are multiple, one second. So to implement, so this is not that much important, but you can go through this slide. So directly I'm going to the framework side, framework part. Okay. Agentic AI frameworks. To implement these frameworks, we can multiple available frameworks are there. To implement these agents, we can multiple frameworks are there, like AutoGen, Lang, that's from Microsoft, LangChain from LangGraph from LangChain, Crew AI from the Crew AI, and Swarm system from OpenAI, Magentic from Microsoft, and Strand from AWS, and latest one Microsoft Agent framework from Microsoft. Multiple frameworks are there to implement these kind of production level systems. But which one to use when to use which one? That is a, what we can say, is a debate topic. There is a direct answer. So based on your use case, you can start you can use any of the framework. But from my experience, I would say that if you want to learn the agent system from scratch, it's always better to start with the crew AI systems. Okay, because as a beginner level, that is more easy to learn and understand. But if you want more, what we can say, a more customizable or a enterprise level systems, it's better to go with Bedrock or Landgraph kind of agents. Okay, Landgraph kind of framework. That's all. Then, very important, when not to build agents. It's very important when to build agents. Similarly, when not to build agents. Don't build agents when you are tasked with the clear fixed steps. Then simply you can go with workflows. Your data is simple data lookup retrieval. Use direct API calls. Real-time requirement. For example, if you are less than 1 second, don't go with agents because agents will take some time, at least around 30 seconds. Too slow. Multiple root calls are there. Then, if you have very budget constrained projects, definitely don't go with agents because if you go with agents, it will be more liable for you. You have 4 to 15 times more tokens will be used internally. Then, if there is a critical or mission critical system without human oversight, don't use agents because agents can make mistakes. As I already mentioned, agents fail more than you expected. Okay, so don't create or use agents in such scenarios. Similarly, tasks where determinism is very important, don't use that. Where you have to use agents, open-ended research and exploration, complex multi-step reasoning, tasks that require adaptation, were solved with the unpredictable branches, and visualization. Oh, sorry, the situations where good enough beats perfect. If you want a perfect system, don't go with agents. But if you want a reliable but a good enough systems, then go with the agent systems. Okay, I hope you are clear. Then the built-in agentic AI applications of agentic AI, it is applicable in everywhere, like in autonomous vehicles, software engineering, and education, finance, and task management, research, everywhere it's using. Then the global agentic AI market. You see, nowadays the agentic AI market is really increasing. Okay, you 2024, we are observing that there is to be a huge market of agentic AI. Okay. Then similarly, as the number of agents the scope of the agent systems is increasing, the challenges and the concentrations in the agent that of agentic AI that's also increasing. Like we have to consider the ethical implications. We have to consider the data privacy and security, explainability and transparency, integrity and compatibility. Everything we have to take care of. Okay. So we don't have much time, and let me go to the demo. So before that, the 2026 will be the year of agentic engineering. 2024 was the year of generative AI. 2025 was the year of agentic AI. Now the 2026 will be the year of agentic engineering. Because I already mentioned, agents are nowadays anyone can able to create agent. That's not a problem. But to make it reliable, persistent, and governed scalable systems, you have to integrate these 8 layers to your agents. These 8 layers mandatory to your agents. These are not agents, these are agentic engineering. Okay, so nowadays the company that will or the institute or a system that will beats others only when they can able to leverage the agentic AI engineering rather than the model accuracy or anything else. Okay, so this is very important. 2026 is the year of agentic AI engineering. Okay, so now let me showcase you a small demo. Okay, I'm showcasing you a very sample demo in the Google Colab using Hugging Face models. Okay, using Hugging Face models only. So don't assume that I'm going to integrate all these kind of 8 layers. No, I'm not going to integrate this because these are only applicable when you are building a enterprise level system. But I'm going to showcase you a very simple system, system in Google Colab using Hugging Face models. Okay, so I'm not going to integrate all these layers. Let me create the yeah. I will share the PPT and notebook with you, so you don't need to do along with me. Let me go to my drive. What you need to do is go to your Google Drive, go to the Google Colab. Okay, so I already have a Google Colab system. Google Colab is already there. So I'm going to showcase you everything in the Google Colab. It's loading, take some time. So what I'm going to showcase is, I'm going to showcase you a simple multi-agent system for the blog creation or a blog writing. Okay. So there I'm going to create three agents. Agent one, then the agent two, then the agent three. Okay. So the agent one is nothing but a planning agent. Okay, this is agent three, this is agent two. This is the planner agent that will plan the topic or for our application, for our blog. Then this is a writer agent that is writing the agent, our blog. And third one is the editor agent that will edit the blog. Okay. So what we are doing? Let me go there. I think it's not loading. I think some issue with the Google Colab now. My screen visible, right? My screen is visible for you. Hello.
Yes, it
sir.
is
Visible,
visible.
sir. Visible, sir.
Okay. I think the Google Colab is not loading for me now. Let me switch the network 1 second. No, I think the internet is it's not a problem with the network. Some issue with the Google Colab only, because only Colabs are not loading, or other sites are loading. Right. You see, everything is loading, but only the Colab has some issue. So give me some time. Okay, let me restart my system. Okay, give me 2 minutes. Okay, let me sign out and let me log in. Okay, I will return back within 2 minutes. Seems like some kind of network issue. Okay, I'll return back. Okay, within few minutes.
Some couple of minutes it will take to restart the computer and all because it's a little memory consuming, I think. So meantime, we can gather the doubts and all regarding the session, especially agentic related frameworks and all. So please be patient. Thank you.
Hello, hello. Am I audible? Hope I'm audible, right? Anyone? Yes. Okay. Thank you. So I think my collab is not loading. It's not loading for me. So let me do one thing. I can explain you what I already put in the my cool collab. Okay. And I'll share the collab notebook also with you. Then what I have done in the cool collab is I create as I already mentioned, you see, these are our agents. I created the agent one, agent three. So these agents I created using the Crew AI library. See, this is the Crew AI library. This is one of the best uh, framework that we can use as a beginner. If you are a learner, if you are a beginner, you study the agentic AI. This is the library that you have to start with. You can start with the Bedrock, you can start Langflow, everything. There is multiple options are there, but this is the one of the best one that is useful for a beginner to learn to understand the basics of agentic AI system. So in the Crew AI, one second. Crew AI and go to the Crew AI documentation. You can see multiple options like introduction, installation, and everything. In the go to agent section, all the Crew AI. Let me check the collab again. No, it's not loading. I don't know why. I don't know why. So in the Crew AI, you have to create the agents in a agents and task manner. Like first you have to create your agent in a first you have to create your yeah. See, yes, this way. You have to from the Crew AI. Crew AI can be shared. This Python client is there. Crew AI has a Python client. Go to PyPy. You can install Crew AI. Okay, no, I'm not going to showcase you that. So once you install the Crew, everything I already put in the notebook. Okay, once you go to notebook, you will get a more clear picture. It's very simple to learn. So I'll share the notebook with you. So how you have to use the Crew AI is that from Crew AI, first you have to import the agent. Then the agent section, you have to provide your role, your goal, and your context like backstory. Then what LM you are going to use? I have done the GPT Hugging Face models. So you can provide your Hugging Face model. If you have a OpenAI subscription, you can use GPT for whatever it is. So this is our first agent. Then you can provide or not provide. This is not mandatory. This parameter is not mandatory. But important items are role, goal, backstory, LLM. These are the main parameters. Similarly, if you want memory, there is the option to memory also. Yeah. Yeah. Memory also, you can provide as true or false, whatever it is. Then, similarly, this first you have to create an agent. You have to create a planner agent like this, like planner agent. Similarly, you have to create a writer agent. Writer agent, again, the same method, but you have to provide a different role, different goal, and different backstory. Then you have to provide a editor agent. Then you have to provide a different backstory, and different memory, whatever it is, as per your requirement. Then what you have to do is, so now we have three agents: planner agent, writer agent, editor agent. Then you have to create tasks also. So the Crew AI is working like a agent and task. What is task? Task is nothing but a detailed guide of managing what to do for the agent. You see, these are the tasks. For each task, tasks. From Crew AI, you can import tasks. So in the task, you can provide a description, an expert output, and the which agent is capable or efficient to do that particular task. Okay, so description. In our case, similarly, we have three tasks. One task for planning task, and the task for writing task, and the task for editing task. and planner task, the agent should be planner. For editing task, for writing task, the agent should be writer. Then the editing task, the agent should be editor. Okay, everything will be in the Google Colab, but unfortunately, it's not loading. It's very easy to learn, very easy to properly format everything. Then finally, what you need to do is you have to create a crew. What is crew? Crew is the organization. This is the organizer. How you have to indicate the crew? Crew is very simple. How you can do in the crew? Uh, yeah. Yes, this is the crew. Finally, you have to create a crew like this. You see what you have to do? You have to provide all the create agents, like create agent 1, agent 2, in our case, planner agent, writer agent, editor agent, etc. Then you have to provide all the tasks, like task 1, task 2, task 3, etc. Like our case, planning task, writing task, and editing task. Then you have to provide your process, like it's a sequential or a hierarchical. By default, is sequential. Then purpose, that is whether you have to showcase the inter steps or intermediate steps or not. Then what you need to provide is that in the crew AI, you have now you create a crew. Then to execute that, crew dot kickoff. This is the executing step. Now you got a crew dot kickoff. Then you have to provide your input here, like which agent which topic we are going to create the blog. In our case, we are going to get a blog, right? So the topic name you have to provide in a curly braces. So in the agent description and task description, the curly braces you can use for the placeholder. Okay. So when you create the crew dot kickoff, then you can able to see that your crew is working. Your crew is first going to planner agent, that is plan the tasks. Then it is going to writer agent, that is writing the blog. Finally, it go to the editor agent, that is editing the particular blog end to end. Then this is the very primary level. Then if you integrate the tools, definitely there is option to integrate tools. You see, go to your agent section. Yes, you see in this agent, data analysis agent, you can create a tool. Either you can create your own custom tool or you can create your own pre-built tool. Go to tools and integrate tools to your agent. Then what happens? Your agent can able to execute that tool also as per the requirement. How you can able to create a custom tool? It's very simple. From the Crew AI, you can create custom tools. Or from Crew AI, you can create a tool decorator is there to make it a custom tool. Let me go there. I think I can showcase you something. Yeah. Yeah. This is the custom tool. How we can able to create our own tool. For that, what you need to do? From Crew AI, import the base tool. Then you have to inherit that base tool in your tool. This is your custom tool. Okay. Then you have to provide the decorator also. This is how you can able to execute tool. Then what happened? The other items are similar. Kickoff, provide the inputs, and the agents, you have to provide your own agents. Then the input will be passed through each agent, execute the corresponding tools. You can able to see each and every steps. In the collab, I can showcase you that. Okay, after I will share, I can showcase you that. So this is the overall idea of the Crew AI agent multi-agent system. Okay, we have created a very basic one with the yeah. Okay, now it's loaded. Now it's loaded. Let me simply showcase you. Very fast. We have only 4 minutes left. So yeah, this is the LLM I created. Then you see, this is my planner agent, my writer agent, my editor agent. Then this is my planning task, my writing task, my editing task. I create everything in together, agents, tools, tasks in a crew. Then what I have done, crew dot kickoff. I put like blog about Indian Army. Then what it is doing, the planner agent is doing the task, and content plan is doing the handovering to writer agent. Then writer agent is handovering to the editor agent. Finally, you see, we got a particular complete blog regarding the Indian Army. Okay, this is without tools. if you want to execute tool, what you have to do? I integrate two tools. One tool to get images from the Google using the base tool mechanism from the Crew AI. Then I create another tool to save my HTML. So then I create one more agent as a web developer agent. What I'm doing, I create the blog. Now I'm publishing my blog in a web page. Okay, so web developer agent. The web developer agent have access to two tools like the HTML save tool and the image get image tool. Then I created one more task for the web developing task. Then what I have done in the Crew, I provide multiple agents. This agent, planner agent, writer agent, editor agent, web developer agent. Similarly, planning task, writing task, editing task, and web developing task. Then what I have done, I ask a question, necessary, ask a simple question. Then it create a entire blog. Along with that, it create the entire PDF, web page, and that particular web page contain the images. Okay, how it is taking the images? Using my tool, custom tool I created. Okay, then it's downloading. Finally, I can able to use that. I can simply showcase you the tool, the web page I created. Yeah, you see, these are the one web page I created. It's very, 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 very interesting. You see, simple, without knowing any of the HTML file, I could able to create a web page like this. Let me download this. Let me download this also. Yeah. You see, this is one of the LLM, one of the web page I created completely using the agent AI. This is another agent. You see, it's not creating, it's loading the images also from the Google. Okay, from the web page. So this is how you can able to create the web agentic AI to create a agent system that is leveraging the tool concept. We don't have much time. Only 1 minute is left because at 7:30 we have another FDP. I know that. So sorry for inconvenience. I'll share this all the PPT and notebook with you. But within few times, let me know if you have any doubts. I can clear with you. I can clear. Yeah, I'll share the IPNB with you. Definitely. I'll share the IPNB with you. Anything I can do, have any doubts or issues or concerns, then you can directly connect with me. This is my contact number. Okay, this is my contact number. You can directly connect with me. My email, my mobile number, everything is there. Otherwise, we can discuss now. Any doubts in the agentic AI system or agentic AI agents in this FTP in this session?
Yeah,
Anything,
thank you,
then we
sir.
can discuss now.
So basically,
Otherwise,
this agents and all, um, basically, can you simply tell me how this AI agents fundamentally different from this kind of traditional AI models or chatbots?
okay. In the traditional chatbot, it is simply generating the output. Like if I ask you the question, it will say that you can do this, you can do that, or this is best way. That's only. But in the agent, allow me to say it will say that, or it will instruct that it will do the things, it will do in the tasks. Like for example, in the chatbot, if you are creating if you want to create a day plan, if you ask the day plan to ChatGPT, let me showcase you. ChatGPT is a generating system now. So let me showcase you. Create a day plan for me. Okay. So it will create the entire day plan, like what I have to do at 6:30, what I have to do at 7:45, what I have to do after 9:30, what I have to do, everything it will do. But if the same question I ask it to an agent, if that particular agent has capable to, or that has a common connection with a timetable tool, or a what we can say an alarm tool, or what we can say a calendar tool, it will set up the alarm at 6:30 automatically. It will schedule a meeting at using the calendar flow automatically. It will schedule a timetable using timetable automatically. So it is actually doing the things. You see, it is only suggesting only, right? In this case, it's not suggesting only. So if it is an agent system, it will doing the things. That is the major difference between an agent system and a generative AI system. I hope you are getting my point.
Yeah.
Hello?
Yes, sir. So one another doubt is here most of us are from academic background. So I was thinking, is there any kind of open research problems, especially existing in this kind of agentic architectures, so that we academics can address that problem and work with our students like as a hands-on projects or something like that, any open source open research problems in this agentic domain, like we can give share with that problem with our students so they can do it as their projects and later go for a research paper or something like that.
So basically, multiple items are there. So I can showcase you agentic projects in GitHub. That's better way. So simply go to GitHub. There are multiple different kind of agentic AI solution projects are there with a proper code base also. So you can simply go to, you see multiple items are there. So go to, yeah, you see using Crew AI, using Autogen, using Agno, there's using LangGraph. Simply go there and pick a system or pick a problem and try to solve this using the open source component. I'm not recommending to go with the OpenAI or a paid subscription. You can able to solve everything using Hugging Face model, because in this demo I am using Hugging Face models. This is the best way that you can do for a learning purpose, the agentic AI. So everything is there in the Google, in the GitHub. The advantage of GitHub is that it's a versioning, means the corresponding owner is updating the particular system, the source code, everything. Else you can simply go to the Crew AI. Similarly, go to Crew AI. Crew AI projects. You see Crew AI projects. You can go to project. Crew AI examples are there. You can use that. Multiple options are there. GitHub is the one of the best solution or a reference link that you can refer, not only for you, for students and everyone. Is this you are asking or anything else? Hello.
Sir, I have one doubt, sir. I am Pradeep. Sir, normally in the network have 7 layers. They are always a reference layer. Here, sir explained 8-layer architecture. These 8-layer have any relations or references there from the 1 to 8 layers?
You are saying this layer, right?
Yeah, this 8-layer architecture. This, yes.
This
These
one.
8 layers, any relations or references there?
You are saying that how these 8 layers are communicating or relating with each other. That
Yeah,
you're
yeah,
saying?
yeah, yes.
Yeah, it's relating in the sense. You see, without, if you don't have a proper infrastructure, then you cannot able to build a proper truth calling layer. Similarly, if you don't have a proper memory layer, definitely your agent cannot able to cannot able to access that particular memory. Or sorry, if you don't have a particular A2A agent protocol layer, then definitely you cannot able to cognition layer will not work. So every agent layer is integrating with each other, but the overall picture or overall idea or a overall goal you will receive when you're integrating these agents, all the layers into your system. So the question is moreover how these layers are integrating with each other. The question should be how these layers are helping the agent system. So what I'm saying is each layers are depends each other. Without a proper infrastructure layer, you cannot able to provide a proper tooling. Without a proper internet layer, you cannot able to provide a proper protocols. Without a proper memory layer, you cannot able to provide a better application to user. Without this infrastructure layer, you cannot able to deploy your agent in a governed layer. So everything is relate to each other, and each layer is mandatory and must have layers, not a optional layers. So everything is dependent and linking with each other. all the layers.
Okay,
If there is
thank you.
no layer,
Okay.
if there is any lag or a problem in this cognition layer, definitely it will affect in your application. Definitely it will affect in your what we can say protocol. If there is any issue with the protocol, definitely your agent cannot able to hand over in the application layer. So everything is connecting with each other. You are getting point.
Okay. Thank you, sir. Okay, thank you.
I'll share the PPT and notebook with you, then we'll get a more clear picture. Okay.
Okay, thank you, sir. Thank you.
Yeah. Anything else? Hello.
Yeah, so any other questions? I think no. So, Sri Lakshmi Madam, we can conclude.
Yes, sir. So, thank you, Pradeep sir, for your wonderful session. It was really great having with you today. We had a great insight about the classes. Thank you, sir. Thank you for being with us.
Thank you. So I will share the PPT. Sorry for the again. I'm saying sorry for the inconvenience to render the good work. Some network error happened. I will share the notebook and PPT with you. Okay.
Thank you, sir. Thank you.
Thank you.
Good night, sir.
Thank you.
Sri Lakshmi Madam, I think we can start the next session.
Yes, sir. So today we'll be having the next section, that is for the day 3. We'll be having the session 2. Session 2, the topic of the session is idea to deployment on systems using LLM powered agents within 1 hour. The session will be handled by Dr. Ramya Durai, is currently serving as an associate professor in Department of Computer Science and Engineering in Jain University, Bangalore. With over 20 years of teaching and research experience, she holds a Bachelor of Engineering degree in Information Science and Engineering and Masters in Computer Science and Engineering and a PhD in Information and Communication Engineering from Anna University, Chennai, and an MBA in Human Resource Management from Annamalai University. Her research interests include mobile ad hoc networks and wireless sensor networks. She has published research papers on Scoopus and SIA journals. I welcome you, ma'am, for the session.
Yes,
Now the
ma'am.
session is all yours, ma'am.
Yeah, thanks for the wonderful introduction. So good evening, everyone. Hope the screen is visible to all.
Yes, it is visible.
Yes. So the topic for today is idea to deployment on systems using LLM powered agents. I'm Dr. D. Ramya Durai, Associate Professor in the
Madam,
Department
the PPT is not visible. Only your screen, that folder is visible.
Now, oh, is it visible?
No.
Oh, just a minute.
Yes, now it is visible. Everything is fine.
Okay, sir. The second slide is visible?
Yes, visible.
Yeah, thank you.
Hmm.
So the topic is idea to deployment on systems using LLM powered agents. So what is the journey for this 1 hour that we are going to discuss this? I'm going to discuss about the AI concepts and the prompt, the introduction to NLP and LLM, introduction to AI tools and models, and we have some hands-on exercise for today. So what is the prerequisites that you need to know is the basic AIM and ML concepts, some knowledge of AI principle and techniques, and knowledge on Python programming, and we have the curiosity to learn now. So the objective is the knowledge of AI tools, knowledge of LLMs, and the practical deployment of LLM. So let me start with the introduction with the AI. So what is AI? So AI, if you talk about, it is a technology that enables the computers, machine to stimulate the human learning and problem solving and decision making. So let me give another example here or other definition of AI. So AI, I can say that it is a technology. So where we can see that it enables the computers to perform the task which is required for the human intelligence, like learning, or it can be problem solving also, or understanding the language and recognizing the patterns. So by AI, we can say that it processes the vast amounts of data to make the decision on predictions. So in this, I have given a small picture to give a brief idea about AI. So as we know that AI are the machines that can think similar to our humans. And what are the types of AI? So broadly, we can classify the AI into narrow AI, general AI, and super intelligent AI. So when I talk about narrow AI, this narrow AI, it is intended for specific task. So it does only specific task. So it can be something, examples like Alexa, Siri, Netflix, Spotify, or it may be chatbots, facial recognition, etc. So when I talk about the general AI, so general AI, it also uses the ML models, and the best examples for this could be the Gemini, or it can be any human. Sorry, it can be also some examples like GitHub, etc. So in super intelligent AI, when I talk about super intelligent AI, is not practical. It's a theoretical approach. It's an hypothetical software based AI system with an intellectual scope beyond the human intelligence. So the current advanced narrow AI examples to talk about, I can say LLMs like ChatGPT or Gemini are the best examples for advanced narrow AI. So let me come to the next part, how AI works. So when you talk about this, how AI works, here the data input. So data input is like it can be any input. The data input can be either a text or it may be an image or it can be an audio or even it can be numbers. So this AI systems will first receive the data in any of this form and this learning, this AI what it does is it uses some algorithm. It is based on the input, data input what we give. It analyzes the patterns. It learns the patterns from the data using machine learning algorithms. And based on this, it is able to predict or it can make the decisions. So AI uses ML algorithms to analyze and solve the problems. So I can give a best example for this. Data input, when you talk about, I can say that photos of cats and dogs can be given as the input, which is the data input. So in the learning and training, when you talk about, so what it learns the based on the patterns here, I mean, it can be the ears or tail or the shape of the dogs or cats. So how it distinguishes the cat and a dog. The next, making decisions after the training happens, after the patterns are being recognized, it is able to understand or it is able to predict this is a cat or this is a dog. So the clarity of the data is very clear based on this particular pattern recognition. So this is how the AI preliminary works. And AI, as we know, it is in our lives in day-to-day life. Either we use smart assistants or we use autonomous vehicles in healthcare or any way. AI is transforming the life and it is making transformation in all the industries to say. So the next, the topic is what is ML. So whenever we talk about ML, ML is nothing but a subset of AI, or it is a branch of AI which is enabling the computer to learn from the data and it improves automatically without being explicitly programmed. We need not give any programs, we need not write any programs explicitly. So this takes care of it. So how the machine learning works? So it is, I have given it in a very simple diagram. So first is the data collection where the information is gathered here or the data is collected, and next the data is being processed here. So in the data processing, we organize and clean data. And next is the training. So training is here we are creating some AI programs and we are training the model. And based on this model prediction happens. So we are using the model to predict the answers. So this is how the machine learning works. Actually, to talk about with respect to this diagram, the data collection and data processing, this all comes under the data science. Only the training model is exactly what ML is. So as we told previously, we have the data and the machine learns from the data and it makes the predictions or makes the decision. So next, coming to the most important part of today, and before that, I would like to give an example for machine learning. So machine learning, as we know that it gives most of the recommendations. Say for a best example, it could be movie recommendations, or it could be the email spam filtering, or face recognition, or it can be face detection, or fraud detection, self-driving cars, etc. are examples of our YAML. So next, coming to the next part, what is LLM? So LLM is a very, very important part for today. And LLM is abbreviated as large language models. So we have a number of LLMs. It is an AI model where it uses the transformers. So we use a concept, the LLM uses a transformer as a concept. So transformer is what? Transformer is nothing but it is the backbone of LLM. So this LLM is trained on the massive text data and it is used to understand and generate the human-like languages. So here I will be discussing about how the transformer works with a relevant diagram, and then we will be talking about the deployment in the last part. So here I have given another paper which is Attention is All You Need. So this is a paper written by the authors like Ashish and somebody. So where they are bringing the transformer model into reality. So I wish all of us to go through this in the later. So again, putting the LLM into a very simple form, I have this LLM, the large language models, so which are the advanced artificial intelligence systems, which is mainly designed to understand, generate, and manipulate the human language. So mainly, as I told you, this is based on the deep learning architecture, which is called as transformer. As mentioned, transformer is the backbone of our LLM. And this other way, I can call this model as an encoder-decoder model also. So next, coming to the characteristics of LLM. So characteristics, when I talk about, I have mentioned here the 4 different characteristics here. The first one is the scale. So there are billions of parameters. So where the weights are that the model will learn during the training. And next, training data. This is the other characteristics. where here there are the training happens on vast amounts of data. Like it may be the data from the books, from the websites, from the articles, from the papers, or even it may be code and more. Next, talking about this, the capabilities. So capabilities, what the LLM does is it can generate the text, it can generate the answer to the questions asked, or it can translate from one language to the other language. It can also summarize the content, it can write the code, and it can do lots more. Coming to the last characteristics of LLM, it is the contextual understanding. So when I talk about this contextual understanding, I can give you a simple example to make you understand this. That is, say, if I give you a sentence like this, we can just guess what the next particular text could be. Say, for example, we are going to a blank. The hero in this dash is Shah Rukh Khan. So it is obvious that we can understand that we are going to a movie. Movie would be the text, and the hero in this movie is Shah Rukh Khan. So this is what is the contextual understanding here we mean. So what it does is it generates the text based on the context that we are providing in the input. And now coming to the most important part of the LLM, which is the transformer. So here that I have just given the diagram to make you understand what a transformer exactly is. So here when I talk about the transformer model architecture, so here we are classifying into two parts, encoder and decoder. So encoder on the sender side and decoder on the receiver side. So encoder, what we do is, here the user will understand the sentence. Say for example, any text, whenever any sentences when we talk. Say for example, I am talking about a sentence, welcome to FDP. So what happens here is, welcome to FDP, it is a sentence. It is a sentence of 3 words. So this is considered as tokens. Welcome is one token and 2 is another token. FTP is another token. So the numbers are given to this. That is the token numbers like 1, 2, 3. It is based on the sentence. So welcome to the FTP. It is the input given to the LLM, where the LLM will be splitting this particular sentence as token 1, token 2, token 3. So the numbers are given like this. And this is what we call it as positional encoding. So that is what is given here. So you can see from the encoder part, the inputs are given here. So the inputs are given here. The next comes the positional encoding. Positional encoding here is the sentences are given or converted into tokens, where the tokens are being specified with the numbers. That is token 1, token 2, token 3, etc. Numbers, where it is the positional encoding. Okay, so I can say that the transformer parts from the positional encoding. So next, when you talk about the encoder, the processing happens in a multi-head attention. You have multi-head attention and feed forward. That is, I can say that the encoder is classified into 2 parts or divided into 2 parts like multi-head attention and feed forward. So in multi-head attention, I can say that it sends the processed data to the feed forward, where it is the second part of the encoder. So what does this does is, the encoder generally to speak about, it gives the whatever input is given, the input is split into multi-heads. And this is being given to the model. It says what would be the next token. Say for example, I say today is dash. So that means today is maybe Wednesday, or today is some sequence is being given there. So that is what is given by the multi-head. Next to the feed forward, we are saying that this processed data is being given to the feed forward. And here I can say that this is mainly for partitioning or sequencing only. And next, in the positioning, whenever I talk about the position 1, position 2, position 3, that is the naming of the tokens, the numbering, it uses some of the activation function. The activation function can be something like a ReLU function. The ReLU function is something like rectified linear unit, which is an activation function, and this is mostly used in neural networks also. So this is used, and this happens in the encoder. The same way on the decoder also, we have some other levels to say. See, we have something called as softmax. Softmax, if you see, which is at the top, where it is another activation function used at the decoder side, that is at the receiver side. And linear also, I can say sometimes it can be optional also. So what this linear function does is, this predicts what what would be the next token. So actual prediction should be accurate. So that only we are using this softmax. Other than this, whatever the other functions which we are told here in the encoder, similar in the decoder side also, we have the multi-head attention and we have the feed forward, etc. So this is the components of LLMs. So where I have the inputs and input embeddings, the positional encoding, encoder, outputs, output embeddings, decoder, linear layer, and softmax. So whatever I have told now, I have just given it as an detailed description here. Just to talk about inputs and input embeddings, as we saw the tokens. So how are we classifying the tokens? Based on the sentence, the tokens are being classified. So the tokens, who is going to enter? We are going to give the sentence, the input. So these tokens are being entered by the user, which are considered as the inputs for the machine learning models. However, as we know that models only will be able to understand the numbers, not the text. So these inputs will be converted, should be converted into the numerical format, and that is what we call it as input embeddings. So input embeddings, whenever we say, it is nothing but representation of the words, which can be numbers, which is machine learning models that can process. So during this training, what happens is the model will be learning how to create these embeddings so that the similar vectors will be representing the words with similar meanings. Next comes the positional encoding. So positional encoding, as I told you that we are going to use this to encode the position of each word in the input sequence as a set of numbers like token 1, token 2, token 3 based on the particular words we have. And these numbers only can be fed to the transformer model along with whatever input embeddings we have. Next, encoder. Encoder will tokenize the input text into sequence of tokens like individual words or subwords. So then we are applying this to the self-attention layers. And outputs, when you talk about the right side, which we have on the receiver side. So during the training, what happens is the decoder will learn how to guess the next word. See, as I told you, today is dash. When I say today is, it may be Wednesday or Friday or whatever. So this next word will be guessed by looking at the words before it. So to do this only, we are having some output sequence over the spot on the right. So that's why the decoder can only use the previous words. So output embeddings, as we told in input embeddings, how the particular text will be converted into words, into numbers. The same way here also, the models will not be able to understand numbers. So we have to change, the output must be changed into the numerical form, which is known as the output embeddings. Here also, as we know, the output embeddings also will be go through the positional encoding, which will help the model understand what is the order of the words in the sentence. So decoder, so this is the part of the model where we are generating the output sequence based on the input sequence. So during the training, the decoder will learn how to guess the next word by looking at the words before it. And as I told you, linear layer and soft max. So these two are used at the top before receiving the output. Softmax, as I told you, we need to have the accuracy of the output. So definitely the softmax function is again used to generate the probability distribution for each output token in the vocabulary. So in this way, we are able to generate the output tokens with the probabilities. So that's about the transformer part and LLM model, which we have discussed. So coming to the LLMs in a nutshell, I have just given you a simple example, or simple diagram. So to make you understand what LLM is exactly. LLM is an advanced AI which is designed to understand and generate the human-like language. Okay. So here we are first training the training happens. What we do is we learn from we in the sense the LLMs learn from the huge amount of data, text data, and it understands the language and the context, and it generates, it actually produces the, or it gives a response to the text. And the applications where we are using this, it can be used in the chatbots, or it can be used in writing, it can be used in coding and lot more. So I can give an example for this also again, like Suppose if at all, if I want to inquire about a college to join for some course, so when I just inquire for the college, every time I get a response, something like a chat. It's nothing but the chatbot. So all this are the applications of the LLMs. So the next topic is LLMs and GPT. So LLMs and GPT. So GPT, as all of us are familiar with GPT, we use the most popular GPT, which is our Chat GPT. So GPT is abbreviated as Generative Predetermined Transformer. Again, it is a transformer. It is a specific type of LLM. So which is actually using the architecture, that is a transformer architecture, which we have just seen. And based on this, it is able to generate the human-like text. An example for this would be the Chat GPT, which the Chat GPT model versions like GPT 1, 2, or till 5. So here I have given a simple diagram to make you understand between the LLMs and GPT. So LLM, when I talk about, again, it is the advanced AI, which is able to understand and generate the human language text. And next, how it works, we have already seen. So based on the training the data sets, and it's able to understand and predict the language. And GPT, when you're talking about, again, it is a type of LLM. This GPT, it is being developed by OpenAI. So, and what it can do, exactly to talk about, it can answer to the questions, it can write the contents, it can generate code, it can assist chatbots, it can give you pictures and whatnot. Everything can be done here. And next, when you talk about the GPT, it is a generative pre-trained transformer, which we have seen. It is an advanced type of LLM. So mainly it is designed to generate the human-like text. So this is in the nutshell. So next, coming to here, I have given you a sheet of LLM regarding what is an LLM, which we have discussed here. And it trains on large data sets. And mainly it uses the transformer architecture with the self-attention, and it produces text one token at a time. How much of our words we give, the sentences we give, text one token at a time will be produced by this LLM. And to understand this particular LLM, you can just see the roadmap of this. So first, as we told that Python language is mostly needed for understanding this, and NumPy, Pandas, or ML fundamentals is necessary. And we can understand the classic ML and deep learning. And next, we need to study the transformer attention and encoding, and using the PyTorch and Hugging Face tools. Yes, Hugging Face these days, it's the most popular, everyone uses. And the practicing the prompt techniques, it can be zero shot or can be few shot or COT, etc. And then we are fine tuning with LoRa or QLoRa, and you can also build this rack systems, and you can explore this agenting AI, and you can deploy with fast API, or it may be Docker or Hugging Face spaces, etc. So this is the roadmap here. And how the LLM works, pre-training is given, tune happens, and evaluation happens, and finally we are deployment is the last stage. And we know that we have prompts also. I think you would have come across this prompt engineering also, and we should know how to give a prompt in a simple way. There are good prompts, bad prompts. I'll just show you with an example. So where we are tokenizing here, attention and generation happens, and we are decoding, and we have this RAG also, and RAG, again, user query is there where we are embedding, retrieving, re-ranking, and generating the output. And agents, when you talk about what is the goal of it, how the task has been decomposed, and the usage of this tool, and the memory updates, and finally the output. And next one is like, again, talking about the tools. So what are the tools available? So the tools can be like Crew AI. Just now, I think the previous speaker was talking about Crew AI. And next we have Pi, Gemini, AutoGPT, Llama, and Flamingo, and so many other tools are listed. I will be sharing you all this PPT so that you can just detailedly go through all these particular tools. And there are different types of use cases of LLMs. So where we have this data analysis and natural language queries, data classification. Data classification, we can see how we can categorize the data by sentiment or by topic or type. And next one is like decision support. How are you going to provide the data-driven recommendations, explanation, etc. And So the features again, what are the other features which are provided here? So multimodal support is this. So where you can process the test, which you can combine the images along with the audio, etc. And again with the scalability, just now I told you. So we can handle the large data sets very effectively and efficiently, and it is more customizable, and it is self-supervised learning. Okay, self-supervised learning. So generally, we know that there are different types of learning, and neural networks also you would have come across like supervised, unsupervised, and reinforcement learning. So here it is self-supervised learning, and it is easy to integrate. You can connect this with databases and analytical tools as such. So again, retrieval, this RAG, when I speak about it, is again retrieval and generation. So that is one thing I would like to add up here. So this is the LLM flow. What is LLM and the use cases of LLMs and tools of LLMs and features. So coming to the next part, I'll be just briefing you like slightly about GenAI capabilities. Again, GenAI is otherwise a generative AI, which is an AI. It's a type of AI where we can create the new contents, whatever we want, something like text or image or audio, video, or code by learning the patterns from the existing data. This is what we have been telling from the beginning when I spoke about AI. So we have the data, we are processing the data, like the particular machine, the model learns from the data, learns the patterns, make uses of the patterns, and then it uses to predict the output. What would be the predictions? It just makes up. So understanding this Gen AI, why or what is the Gen AI does is it can create the particular so you can create the new contents like music or anything else. And the data input, it uses the data and algorithms to generate the original content. So examples of Gen AI can be like text generation, or it may be images, music, or code generation. And what would be the benefits? So mainly you can save time. The search time is also, saved, and you can personalize the content what you would like to need, and you can automate the task, and definitely it can also boost our creativity. So in putting it in a nutshell, that Gen AI can create the new and original context like verse, pictures, or code, or what else. So next, this is the glossary of whatever we have discussed. So I have a simple diagram, like a Venn diagram. It's not a Venn diagram, a diagram to show you AI, ML, Gen AI, and LLM. Okay, so we know that machine learning, it is a subset of AI, and we have Gen AI, we have LLM. So we have spoke about all these aspects. So examples of AI, again, which we have seen there: chatbots, autonomous vehicles, so game playing AI, robotics, and all other things which we have discussed in the previous things, and even healthcare. So to diagnose the diseases or to personalize the treatment, all we use this in healthcare, and in financial sectors or in customer services, we use this AI. So let me not touch more about AI. Next, examples of ML, as I told you, face recognition, spam, email spam filters, predictive typing, and fraud detection. So this, we know that machine learning is an algorithm that will definitely enable the computers to learn and make the decisions from the data. So again, some more examples which I would like to say for Gen AI, it would be Chat GPT, DALI, Midjourney, and it is GitHub Copilot, and Synthesia, and NLP, natural language processing. So we have some of the examples here, which is used for sentimental analysis. So where you can determine the customer satisfaction from the reviews. So we know that this is mostly used, again, when you talk about the reviews, even we go for purchasing a product based on the customer reviews, right? So reviews plays a very important role. And machine translation, when I talk about, we can translate from one language to another language. So that is a task done by the Google Translator. So this is one of the example of NLP. And chatbots or assistants, we can say, you can converse any or do any interaction with the users like Siri or Alexa, etc. And text summarization, when you talk about, you can create the summaries of long documents. Speech recognition, you can convert this spoken language also into the text. So text to speech or speech to text. So speech recognition will be converting the spoken language into the text. And again, here I'll not much go into LLM again. Just now we have seen the language task, transformer architecture, deep learning. Yes, deep learning is also essential. Deep learning neural networks and text data, all this we have seen. See, this working of LLM I have discussed with you with the respect to the transformer model architecture there. Here again, the same thing is simplified and I put it here. You can just go through this in the later part. Input tokenization, embedding, contextual processing. Hope you understand this contextual processing. I just gave you an example with, I'm going to a blank. Uh, so the actor in the dash is Shah Rukh Khan. I gave an example. That is the best one here. So prediction, decoding, and output generation. So output generation, whenever you see whatever output is that you obtained, it is converting the sequence, whatever we get, back to the human readable text. So these are some of the characteristics of the LLM. So where we have the context understanding, the context understanding, when I talk about, it is the ability to interpret or to translate the information within its context. And we have the reasoning skills, the capacity to draw the logical conclusion, and we have billions of parameters. The vast amount of data are used to train AI models, and we have the grammar learning. So here it is an ability to understand and use the language rules. And the fact learning is like what is the acquisition of the facts, the factual knowledge from the data given. So all these advanced AI models. So now coming to the code basics, I will just show you now with I'll show you the deployment now. So before that, I just want to show you what I have given here and why I have put you some of the codes here. Because the deployment, what I'm going to discuss with you, the explanation of that I have put it here. And whenever I talk about the code basics here, the language codes, here I have taken some languages and what would be the language codes for that particular language I have given here. Only this slide I will be showing here, and others I will go to the Colab and show you how the particular, a simple example of deployment, I will just show you the detail. So the language codes of English. So if I want to specify the code for English, I want something in English, the code for that English is ENG_ELATN. So next when you talk about next, I talk about the other language, Tamil. This is TAM_TAML for Tamil. And for Hindi, it is HIN_Deva. So, Telugu, TEL_Telugu. Kannada, KAN_KNDA. Like this, we have the language codes for each and every language here. So here, I have simple deployment program which is given here. And for each and every code, I have given the expression here. If you talk about this first, from transformers import auto tokenizer, auto model for sequence to SEQLM. So what is this particular code? This is all I have written it in the code there. So what is the explanation of this particular code here I have given? I will just brief you here and we will go to the code. Or I can just go to that deployment directly. Let me just show you here. And this is whatever I've given in model name. Model name equals some model. This is our LLM. This is our LLM. Okay. So this red lines, whatever I specified in all the sheets, it is the code that which I'm going to use it in my Colab now. This is the tokenizer. Again, this is the others line code. This is the fourth line, fifth line, and this is the sixth line, 7, 8. This is a very small example I have taken to make you understand. It's hardly some 10 to 12 line code. Okay, so I will be carrying out that in the deployment now. So again, a small idea about a prompt engineering. So prompt, it is a person or performance in person, how we can do the same way where we can give some instructions in the natural language and we get some output. So we have to be very smart in giving the instructions or giving the prompt, So we have to be very smart to give the instructions smartly. So that is prompt engineering. So again, we can, with the help of prompt engineering, all of us know we can get the works done easily. It may be a grammar correction or summarization or text generation, translation, etc. So how to structure the prompt effectively? So we have the context and the instruction. We can give examples, constraints. Okay, so when I talk about the constraints, it is providing some background information to help the model understand the scenario, what exactly we are going to ask, the user is asking. An instruction will clearly state what the model should actually do. And next example is it will guide the model what style of response or which type of format it should be given. And next constraints, when you talk about it will specify the limitations to refine the output. So I have given here a simple example for a bad prompt and a good prompt. So whenever I say that prompt, give a simple prompt like explain AI. If I say explain AI, it gives too much of information. So that's why I can say it's a bad prompt. For a good prompt for the same way. So I just need some idea about AI in 2, 3 simple lines. So which can be suitable for some UG students if I say with one real world example. This is a simple or a good prompt. So what is good or why I say this to be the good prompt? Because it defines the purpose of the instruction given, the prompt given. It defines the purpose and what is the tone, what is the recipient and the length of the particular prompt. So here, whenever we talk of the prompt engineering, when the explicit methods are used, so where all we are using, the code automation is there, complex max we use, precision is needed. So because high accuracy is very much required, right? So that is important. And visualization also matters. So any data, it needs a very clear or visual representation. So code automation, when I talk about, it requires a code or it requires an automation. So you can also just state the problem naturally. Suppose if it is matching with any of the patterns which are seen before, it will handle accordingly. So if you're unsure of what to give, use a hint like calculate or simulate or plot or automate or model. So now coming to the hands-on experience. So now I will be talking about the deployment using the Colab. So which is the Google Colab. And Google Colab, when I talk about, it is a free cloud-based platform to code in the browser. So it is a freeware. It is a open source. Like see, this Google Colab, when I say it is basically a Jupyter notebook hosted on a remote cloud. That is, we are going to see an example where I'm going to deploy the particular code. I'm going to write a code and deploy it on the cloud. Okay, so we are going to deploy the LLM on the cloud. So this Colab, I'm just briefing you about the Colab. It has access to GPUs or TPUs and even most popular machine learning libraries. And it can also run within multiple languages like Python, C, C++, etc. So background, what is on the background? It is Ubuntu, which is running on your cloud. So which will make you to the do the task at the simple level. So just like our playground, we can enjoy the learning here. And coming to the deployment part, we are actually, I have an example here. Sorry. Once again, I'm just sharing my screen again. Just a minute, it's getting open. Are you able to see the screen? Is my screen visible?
Yes, ma'am. It is visible.
Screen is visible, ma'am.
Yeah, thank you. Hope the particular collab is visible to all of you.
Yes, ma'am.
Yeah, thank you. Okay, see, I have taken an LMM, so I have written a code already because we don't have much time to text the code here. So to make you understand, see, this is a very simple code that I have taken. I have given one text and I'm going to convert the text into some other language. Okay, so this is the deployment that we are doing using LLM. So the first sentence is like, I think now I can relate it with the slides which I told you the previously, which I've given the explanation of each and every line I told you, right? So the first sentence, what I've written here is, I have opened the Colab and I've given this from auto tokenizer, auto model for sequence to sequence LM. So it can be any example also. Suppose I can say, give an example like welcome to FDP. So here what I mean to say is we are using an auto tokenizer here. So this is a type of library that we are using. That is the library in the tokenizer. This is the library in the tokenizer. Auto tokenizer means it is a library in the transformer. Okay. So now under here, I can say that we are going to import this automatic classes from this Hugging Face. So whatever I am talking is with respect to this particular first sentence only, the first line of the code. Okay. So we are importing the automatic classes from Hugging Face. Maybe Hugging Face is nothing but it is a transformer, I can say. And all these particular classes will automatically select the correct tokenizer and the model. So this is, I can say this is the best practice for the multilingual LLMs like NLLB. I think you have heard of this word NLLB. That means no language left behind. So what is this NLLB? NLLB means it is nothing but your multi-language, multilingual, it is large language model. So this is being developed by Meta AI, that is a Facebook AI. So mainly this is for machine translation. So what is the purpose of using this is, this NLV, it will strongly focus on the languages like Tamil language, Telugu, Kannada, Hindi, etc. So for that is the reason that is the explanation for this particular sentence. We are going to import the auto tokenizer. That means we are using some auto tokenizer, which is a type of library in our transformer. So default, I'm giving this particular sentence or the code. And next coming to the second part, model name, which is Facebook / NLLB -200 at distill -600. So what is this? This is the model name. See, this model name is our LLM. What we are written, this is our LLM. So this model name, again, I can say that it is a variable name. I have given it as model name. You can give your name also. Any name can be given here instead of model name. Okay, I can change my name also here and give. Okay, so now what is this actually, this particular sentence, I can say that this is our, this will specify the large language model, pre-trained language model. As I told you that here it is, what is this 200 is, we are using NLLB 200. I just told you NLLB means it is the no language left behind. Okay. So here what it does is this 200, when I say this, suppose 200 plus languages. Okay. And this till the 600 M. So this is nothing but it is a small, or it is a faster version which uses 600 million parameters. So that is the understanding of this particular second part of the code. Okay. Hope this is clear so far. All of you are able to get it?
Yes, ma'am.
Okay, thank you. So this is the second text. And I can say some more details on this, like it can be a predetermined model. As we can't develop now, I'm using this predetermined LLM model. Okay, this is an open source. It's easy. So generally, if you see, there are different types of keys, like some are public, some are private here. So if it is a private one, key will be given by the owner and we have to pay and buy. But this is a open one. This is a public one. Okay, that's what I call it as open source. And the model name here I've given, please note down here I've given the variable name as model name in the second sentence. Okay, so next moving to the, so please understand this is our LLM which we have created. Next, coming to the third sentence, tokenizer. Tokenizer is equal to auto tokenizer dot from pre-trained model name. Okay, so what it does. So how are we going to download the NLL auto tokenizer? So that is what is this particular sentence talking about. And again, wherever I told about model name, so this model name, the variable which I have used model name, the same thing only I have to use it here. Suppose if I give the model name here as Ramya, then here also in the tokenizer, the last part I have to give it as Ramya only. And next model. Model equals auto model for sequence 2. Sorry, first let me give you some more details on this tokenizer third sentence itself. So what this particular third sentence does, the tokenizer is equal to auto tokenizer dot from pre-trained. Here it is the model name which is the pre-trained model. Okay. So if I have given today, as I told you, the model name should be today everywhere. Okay. So what it does is here, if at all, if I give a text like welcome to FDP, so what it does is it will split I told you the sentences will be split as tokens. Okay, token 1, token 2, token 3. Each and every word will have one token. So this splitting will actually happen here. So I can say in this sentence only, it downloads the NLP tokenizer and it will split the text into subwords or tokens. Okay, what again it can handle is it will handle different types of Unicode scripts. So like Telugu language, Telugu, Tamil, Hindi, etc. And we also have the language codes like English language or Tamil language, etc. Okay, so this type of language codes also. That's what in the introduction in the slide I have given some 4-5 languages and the codes for the particular languages that what we are going to use here. So coming to the next sentence, so we have something like model equal to auto model for sequence 2 sequence LM dot from pre-trained model name. So here what this particular statement does is it will load the transformer based encoder decoder model. Hope you are able to understand why I gave more importance or discussed about the transformer, because this is what how the loading happens or how this loading happens. It loads the transformer based encoder decoder model. That is what is this sentence. So mainly if you talk about in this particular model, we are talking about how we are designing different types of sequence to sequence tasks. Here 3 types of tasks can be performed. One is the translation, one is the summarization, and another text generation. 3 tasks can be performed. So what is that translation? So translation, when I talk about the tokens can be translated from one language to another language. So that is translation. Summarization. When I talk about summarization here, summary can be like, say I give you a paragraph and I want it in a single line. So the summarized version of the whole para into single line, that can be another task. So why I'm talking about this is this particular model, it is designed to perform sequence to sequence task that happens in this model. And the last part about this task is the text generation. What is text generation? We can generate a text. I already gave an example. I went to dash movie. I watched Shah Rukh Khan movie. So this is generating a text. Just based on the previous words, it just assumes and it provides or it generates the text. So the language code we have. So based on that only we are discussing. And the next one is like the tokenizer. So tokenizer dot source language equals English language. Here what I'm doing is I am setting the source language. Okay. So what is the language I've discussed here? That is my input language. Here the source language I mean to say it is my input language. I'm giving my text in English. So what is the code for English language? The code for English language is English_Latin, LATN. Okay, so now text. What is the text that I'm going to give? I told you this is the code I have written to convert my text into some other language. Here my text should be in some language. My text is an English text, and that text will be converted into the language what I have defined. Okay, so here the text what I have taken is natural language processing is important. This text should be converted into some other language. Okay, so next, so here this particular line tells that the NLB tokenizer, which is the input text. As I told you, English Latin, it is the English written in Latin script. Okay, and NLLB, again we are talking about NLLB everywhere. NLLB is many to many multilingual model here. It is a multilingual model. And also we should see that how it should know the source language explicitly to encode. Only then it can encode the text correctly. Okay, so definitely this particular text is it is required for the particular encoder to encode the text correctly. So next, coming to the next part, the text equal to natural language processing is important. So if at all, if I want to change the text, I can give welcome to FDP or whatever text you wanted to give, you give the text there and specify the language. Suppose if you are giving any text in some other language, specify it in the source language what you want to give. Based on that, your text also should be given. So next, here if you see here, this particular sentence, it is defining the input sentence in the source language. And this sentence will be tokenized, it will be encoded, and it will be translated in the other language. Okay. So language here, I wanted to convert this particular text language into my mother tongue, which is Tamil. So I'm going to convert this natural language processing in Tamil. Okay. So next, the next sentence is that inputs equal to tokenizer, text, comma, return tensors equal to PT. So now here, what is the purpose of this particular thing is, here this is the transformer which will understand the tokens. Okay, so we are converting the input sentence into the format which can be easily understandable by the transformer model. So what exactly happens internally is our text will be converted into subwords or tokens, and the tokens will be generated as numerical IDs. Okay, and we're going to add some special tokens here, something like start or end or language tags, anything. So we are going to convert this output by PyTorch sensors. PyTorch tensors. Okay, so that is what we are giving it as PT. PT here means PyTorch. Okay, and so this is definitely required because the model we have specified it is a PyTorch model. Okay, so that is what is this particular inputs. So next, coming to the last part, the conversion part. So far what I have done in the first part is, so I have taken a very simple example to make you understand. The first part, what we have defined is, we have just told about the LLM. We have defined our LLM. And the second part, what we have done is, we have said the source language. I say that my source language is an English language. And I'm going to give the input text in the, some text I've given it in the English language. So coming to the last part of this example is, I have converted the target language to token to the ID. Okay, so that means my English language, I'm converting it to some other language I told you now. So for this, Tamil language ID equal to tokenizer.convert the tokens to IDs of tam.tamil. See, if you see here, you should understand, right? The transformer should understand which language this English text has to be converted. So I have specified this is Tamil language. Convert this into Tamil language. So this tam_Tamil, I told you the language code initially I gave it in the slide, right? Tam Tamil. And outputs is equal to model.generate inputs post BOS token ID, Tamil language ID, max length equal to 128. So before that, I just want to add on something for this. So we are in this Tamil language, what we do is we are converting the Tamil language token into numerical ID. Okay. So what is this Tam Tamil? Tamil language written in the Tamil script. See, the previously I told you English language written in Latin script. This is Tamil language written as Tamil script. So this NLLB only will again use this particular tokens, language tokens, to control this output language. So now, as we know that models will work only with numbers, not as the text tokens. So that is the reason why we require to give this language code to IDs. Okay, language code to IDs. So next, coming to the last part, outputs is equal to model.generate. So here, if you're talking about here, here we are translated text is here. So whatever the translated text is there in Tamil, it is stored in the output. So the next last sentence. So now here what we are talking about is what are here all the parameters are explained here in this case. And again, what is the inputs, input IDs, what is the attention mask, everything is being understood in this particular sentence. And this all come from the tokenizer. And then finally, all these are fed into the encoder. So your answer, your result converted text from English to Tamil is being kept in the tokenizer, kept into the encoder now. It is fed to the encoder now. So finally, we need to print the particular output. So which is this print statement. So we are printing whatever is that based on that finally we are printing. So that is what is this forced BOS token we are giving, and we are just talking about this BOS. So what is this BOS here we mean? It means that it is the beginning of the sentence. So it is ensuring that whatever the output language we have got, it is in Tamil. So this is what is my code. So now what I am doing is I'm going to run this particular code now. So it takes few seconds to run this particular code. So now the particular code is executing. Since already I've executed the code previously, this particular translation is visible here. So you can just see this. See, hope all of you got this. So now, after this particular execution, so you will get, during execution, you will get all this. Still it is executing a few more seconds to complete the execution. So all of you are able to see this particular code generated. The code for that is equivalent is இயற்கை மொழி செயலாக்கம் முக்கியம். Those who know Tamil will understand. Or you can change this. I can tell you if you want to change it English language into any other languages. So you can use if you want to write Telugu as the script. Then again you can change it. So what changes you should make here, I'll tell you. You can just refer to the particular text that I had given you. Suppose if you want to change the text from English to any other text, like say for example Telugu. So where is the change that you need to make is instead of this tam underscore Tamil, you have to make it as TEL underscore TEL underscore Telu. So if you want, I can change this and show you TEL underscore. See that you have to give the code correctly. If you miss to give this, then it is difficult to. So you can just run it. Sorry, I have to execute the code again. So what are the changes you have to make here? Just check it out. Say here you can convert this. See, even if you give the ID differently, ID wrongly also, it will not give you the result. So see to that, you give the correct ones and execute. So this is an example for your, so all of you please try this. I want to show you another example. I will just switch on to that. So here in this example, we have just translated the English text to some other language. Okay. So now I will just move with the other example. So I'll close this collab and I'll open with other example where I can show you an example for a text to speech conversion. Yeah. It's loading. Just wait. I will not detailedly give you the code fully now. I will just show you how the particular translation happens from text to voice alone with this coding example. So here I thought I have given you some more details to make you understand what is Colab and why we are using, what are the features of Colab and all in the same Colab. I've just added all this. So same will be shared to you. Okay. Yeah. So in this also I have added some more example here. So I have written a simple C code here. You can see here. I've written a code for printing the hello world, just the printf statement. So that once you execute, you get this hello world. As we are running out of time, I'm just showing you the code directly. All of you, please try this and run it. And what are the other Python libraries which we have for data science? NumPy, SciPy, Matplotlib, Matplotlib, TensorFlow, and all this PyTorch. PyTorch just now we have seen there, and transformers. So installing GTTS, what is GTTS? Here I am installing this GTTS. Again, it's a Python library. So with the help of this, we will be able to run the Python program to see that the text is converted into speech. So here is the code that we have written. So from GTTS, I'm importing this. And here what I've done is I have one idea, like I have a poem in my mind. This is my idea. I'm going to deploy this on an LLM or using an LLM, I can say. So here is my poem. The poem is written as two roads diverge in a yellow wood. And sorry, I could not travel both. And be one traveler, long I stood and looked down one as far as I could to where it bent in the undergrowth. So this is the poem that I had in my mind. This is my idea. This I've given as a text. Now I am going to convert the text into speech. So for this, I'm using this TTS equal to GTTS, this particular code. And I'm going to save the audio file. And now I just want to see that once I execute this, already I have executed this particular code and kept it. So now I'll just show you how the particular translation exactly is done. Okay. So this is the second example. I just thought I will share it with you. So let me, yeah. So this is again written in an English language. So just a minute. I'll run this. Sorry.
Two roads diverged in a yellow wood, and sorry I could not travel both, and be one traveler. Long I stood, and looked down one as far as I could, To where it bent in the undergrowth.
Okay, so this is the translation of my text which I have typed here. You can change the text, you can change this text, and you can just see the same thing. Okay, and this is another text to text one from one language to another language conversion. Here, this is the text from one language which is converted into speech. Suppose if you want to change this particular code, the same thing with another language, yes, you can do that also. Let me check. I think I have tried another one also with some French language. Let me check. See, you have please go through the particular code. So French I have written a prompt, bonjour, Jampale Ramya. Hello, my name is Ramya. That is the meaning of that. Okay. So this also you can run and see. As we are running out of time, I will not be able to. I'm disconnected. Let me check. The same thing you can try because there are too many sessions here. I'm not able to check out now. So this particular, it takes so much of time to execute. Just give me a moment. Yeah. It's executing, just wait. I will share you the same code to all of you. You can run this and check it out. Next time. Even if you want to change the other language also, you can change it here. So you can just run this and see. 1 second. Installation is not required again. You can directly go to the other part. Hope these two examples are understood for all of you. So like this, you can execute different types of examples and you can deploy the LLM. So here I'll make some changes. And here I'm just typing you to show that even if your syntax is wrong, definitely it will not work. So that is the reason why I'm giving the code in a different way. Okay. So we can. So that's about this. And so I want all of you please try with the different examples. Yeah. So with this, I'll wind up the session. And any doubts, any clarification? I'll be messaging my email ID. If you have any doubts, you can contact me over mail. Thank you. Any clarifications?
Thank you, madam. So
Yes.
now it's time for Q&A. Madam, one doubt is
Yes, sir.
this prompt engineering and all.
Hmm.
So basically, this what is it? This prompt engineering, is it like a engineering discipline or a like a usability skill or a like a uh, like a temporary workaround? Like what exactly we can define this prompt engineering in which category of the engineering?
So it can be, it comes under a skill. So mainly it is a skill and it is a kind of practice, I can say.
Practice.
Yes, it is a skill only. Yeah. We can't
Mm-hmm.
exactly say that prompt is engineering.
Mm-hmm. So currently, a lot of industry, I think it is going like this prompt engineering is more closer to programming. So, or like a communication between a user or a developer with the machine. So, is it closer to programming, this prompt engineering? Is it true?
So I feel I don't exactly say yes.
Mm-hmm. Okay. So, madam, in your point of view, this prompt engineering should be formally studied or evaluated in the academic practice.
Yes, sir.
I mean, as a syllabus course, like because a lot of people, I felt like they have all the cursor, like a lot of IDEs with the right prompt. We can even develop a full stack application in minutes. So, but a lot of people, I felt failing when it comes to giving the right prompt. So,
Yeah.
how we can make it, what is it, professionally clear for the students, like any best practices or something like that?
Sir, and your question is very apt, like regarding prompt engineering. See, actually, to speak, sir, this we are doing it on trial and error, right? As of it is like prompt engineering. It is like given as trial and error. Instead of that, as you say, like form engineering discipline, like that, if we get, it would be better. So mainly, as we talk about the professional AI development, definitely this formal engineering discipline could be a better way. So we can say that it can improve the performance and optimization of code also would be better. and for testing or other areas also. In the evaluating tools also, this prompt engineering, if you bring it as a separate discipline, it will definitely help the students, sir. Because industry demand is also huge, right? Now many companies are also requiring this prompt engineers only. If you talk about any of the fields like research or any other domains, or any technical roles you see, the industry is also in expecting or having huge demand for this type of roles.
Thank you, madam.
Even there are some course on Coursera also, sir.
Yes, yes. Coursera I have seen.
Coursera courses, so that we can tell students to take up that course and do. So definitely it will be useful.
Yes, madam.
Okay.
Madam,
Yes, sir.
Madam, can you suggest regarding this prompt title, the BTech students, any project suggestions for regarding this?
Sir, can I share you to tomorrow in the later part?
Okay, madam. Okay,
Some
okay,
case
madam.
studies or you want some projects on this, right? Yeah, sir, I can definitely share.
Okay, okay, okay.
Okay, sir.
Hello, ma'am.
Yes,
Hello,
ma'am.
ma'am. Yeah, I have a question for you. That you have given demo on that transformer model, right?
Yes, ma'am.
Hello. Yeah. So if I want to do with that Llama model, right? Llama is given,
Yes.
free
You're talking
Meta
about
AI. Yeah.
DeepSeek.
So I'm talking about that only.
Yes,
That
ma'am.
can I use Llama model with the Google Colab?
Olama with the Google model. I have not tried with that, ma'am.
Okay.
But Olama definitely we will be using with DeepSeek.
Okay, but I tried once, but I think Llama, I think it is failing because of space requirement. Because Llama models are, it requires much space, I think.
Yeah, we can
And
use it with Colab, ma'am. But again,
yeah,
I have not tried this. You can
okay,
definitely try. Yeah, we can
okay,
use this.
okay, yeah. OpenAI API, which API key OpenAI is working over there,
Yes.
and
Now for
Hugging
this,
Face model.
you can, ma'am, this when you're using this Olama with Colab, no, what you can do is you can use this T4 GPU. So if
T4
you want
GPU.
to,
Okay,
yeah, if you want to run from smaller, medium size model, then
okay,
you can run over this T4 GPU. When you go with the connection setting now, there you can
and
connect to T4 GPU and you can try, ma'am.
okay, thank you, ma'am. Because with T4 I didn't try.
Okay, ma'am. Okay.
Yeah.
You can
Thank
try,
you
ma'am.
so
You
much.
can try and check. Yeah.
Yeah, thank you so much, ma'am.
Okay, ma'am. Welcome.
Sri Lakshmi madam, please ask any other questions left. Otherwise, we can conclude.
Sir, let me share my video. I think you're not able to see me, right? Like, just a moment. So just give me a moment. I will just on my video. Like,
Okay, ma'am.
just give me a moment. Let me check with my video.
Okay, ma'am.
Sorry, there is some issue with my camera, so I'm not able to view. So sorry about it. And yeah, over to you, ma'am.
Yes, thank you, ma'am. It's okay. Anyway, just a black screen only. We can see just a black screen only. Yeah, that was a great session on prompt engineering, Ramya ma'am, Dr. Ramya ma'am. And we got a lot of takeaways from the session. Hope all the participants have got a lot of insights regarding this topic. Thank you, ma'am. Thank you and have a great day and good night. Good night, all
Yeah.
participants.
Okay, I thank all the participants who joined here, and I thank the organizers and especially Z Lakshmi ma'am and Thomas sir, Sri Lakshmi ma'am, and the management of Royal College of Engineering and Technology for giving me this wonderful opportunity to address the audience. Thank you all.
Okay, thank you, madam.
All the participants, please do fill up the feedback form of the day 3 session, session 1 and 2. Good night, all.